Are extraterrestrial celestial bodies potentially habitable? This is one of the questions that Earth-based research into distant intergalactic realms is trying to answer. Even though more than 5,000 exoplanets have now been found in more than 3,700 systems, there remains no signs of an exact Earth twin that is capable of sustaining human life. This only serves to intensify the excitement of the news that made headlines a few years ago. NASA staff members had successfully added a few Earth-sized exoplanets to the star charts. Learn more about these fascinating heavenly objects, including what the finding says about their ability to potentially sustain human life. But before we dive into these amazing exoplanets, hello there, and welcome back to the Discover Space channel, where we explore the cosmos and all its wondrous possibilities. Be sure to subscribe if you haven't already, and let's jump into the video. Kepler 16b. The first one is an exoplanet named Kepler 16b. This exoplanet, which orbits two stars, is 245 light-years from Earth. For the very first time, astronomers have successfully used an Earth-based telescope to find the twin star planet. If we look back in time a few years ago, we reach a period in which there was still a lot of controversy around the likelihood of this double-starred planet. Planets often develop in their host star's protoplanetary disk. There were not only one, but possibly two or more of these brilliant heavenly bodies. This gas and dust excretion is subject to significant gravitational disruptions, at least according to an old theory that the universe finally showed to be false. Kepler 16b, which orbits two host stars, was identified by scientists roughly 11 years ago. Since then, there has been a significant increase in the number of circumbinary planets. Some of the discovered planetary systems even orbit three parent stars. The double-star planets that have been found thus far have been identified using the transit method, like the majority of other exoplanets. In this method, the planet itself is not directly observed. Instead, the brightness variations brought on by the celestial body as it revolves around its parent star are observed. However, our perspective from Earth on this global search for evidence also has some limitations. As a result, we can only notice changes in the brightness of the host star when planets travel directly right in front of their star from our perspective. The so-called radial velocity approach to be more precise. This technique is based on the principle that a planet and a star share the same center of mass. Hence, big exoplanets have an observable influence on the movements of their parent stars. Thus, by utilizing this technique, astronomers can ascertain an extrasolar celestial body's mass without having to rely on the apparent direction of the planet's orbit. Experts have been unable to analyze a double-star planet by using radial velocity method for a long time, but that has changed. In the case of Kepler 16b, they have already been successful in accomplishing just that. This intriguing study was made feasible by the usage of a spectrograph in the French department of Aude. Experts were able to identify the exoplanet's minimal influence on its two host stars through careful analysis. This manifested itself in the orbital motions as a kind of minute wobble. The actual celestial body is most likely a chilly gas giant with a 0.33 Jupiter mass rather than a searing hot desert world. The discovery of the first circumbinary planet using the radial velocity gives researchers confidence that they will be able to find more like this in the near future. Future research might then focus on how these planets managed to form in spite of the gravitational turbulence in their binary systems. According to current beliefs, planets may first form distant from their stars before eventually being trapped by them. We may, however, need to entirely re-evaluate the previously understood planet formation methods in light of new research discoveries. TRAPPIST-1 system. NASA announced another exciting discovery in the vast reaches of the universe around 5 years ago. The crew of the space agency has discovered the remarkable planetary system orbiting the red dwarf star TRAPPIST-1. The 7 celestial bodies that were detected were exoplanets that were roughly the size of the Earth, which is what made this fascinating finding so unique. In the course of this galaxy discovery, scientists asked themselves the same question they do so frequently. Is it possible that any of these exoplanets would be habitable? Furthermore, was it possible for life to have already developed there? We cannot be certain. This is not to say that we haven't learned more recently about exoplanets. We now understand that the objects 41 light-years from Earth are rocky planets that may be twice as old as our solar system. Experts are currently excitedly waiting the voyage of the James Webb Space Telescope in order to find answers to the questions unanswered regarding this fascinating planetary system. Webb's main goal will be to study the atmospheres of exoplanets, and it will be bigger and more capable than any space telescopes in the past. The study of the 4th innermost planet, known scientifically as TRAPPIST-1e, has experts extremely enthused. This planet is situated precisely at the center of the area known as the Habitable Zone. If you recall, in the realm of astronomical research, the habitable zone is the distance between a planet and its central star, which allows water to live in a continuously liquid form. For the emergence of life that resembles that seen of Earth, liquid water is a fundamental requirement. The planets in TRAPPIST-1 system orbit their central host star far more closely than constellations in our solar system. In fact, the orbits of the exoplanets in the TRAPPIST-1 would all fit within the orbit of our innermost planet, Mercury. However, this doesn't diminish the possibility of these planets becoming habitable. In addition to being far cooler than our Sun, the equivalent red dwarf star is also considerably smaller. In the hunt for celestial bodies that are conducive to alien life, a planet's geographical location inside the habitable zone is a key indicator. But in this case, it's not the only factor that needs to be looked at. The fundamental requirement is that a planet must have a sufficient atmosphere in addition to being significantly designated as a potentially habitable. Although the atmospheres of the TRAPPIST-1 planets could not be fully understood by the Hubble Space Telescope, the observations nonetheless yielded some fascinating discoveries. Hubble, for instance, was able to verify that at least 3 of the exoplanet TRAPPIST-1d, TRAPPIST-1e, and TRAPPIST-1f do not have the inflated atmospheres like Uranus and Neptune that has massive hydrogen accumulations in the atmosphere, a tidbit of knowledge that was highly appreciated by the researchers. Because it is true that planets with such natural circumstance are thought to be relatively unfavorable for supporting life, another equally attractive prospect is also accessible as a result of the information so far gathered. This suggests that the atmospheres might theoretically permit the existence of liquid water on the surface. The detection of carbon dioxide, however, is what researchers are most looking forward to from the launch of the James Webb Space Telescope. For life to exist on Earth, its existence is also necessary. Planet Earth would be a lifeless celestial body if carbon dioxide were to be fully removed from its atmosphere. So, What do you think about the fascinating planets in the TRAPPIST-1 system? And did you know that there are planetary systems that contain 2 parent stars? Let us know your thoughts in the comment below. And as always, we shall see you in the next video.